Hi everyone, this is Mrs. Bokerman. Let me be the first one to welcome you into the world of parametrics. These short videos is going to kind of teach you the intro and the basics about parametrics, and this video is going to cover how to graph a parametric. So we're going to start with what is a parametric, but what you can see is on this graph, you'll see that you have something that's not a function. And so in parametric world, you no longer are restricted to your functions. So let's get going. What are parametric equations? They're a way for us to represent plane curves. And we're talking curves because it doesn't necessarily have to be linear. Where x and y are defined by parameters, most commonly you'll see them with t. So similar to vectors, when we had vectors, we were able to talk about what's happening horizontally and what's happening vertically. Very similar, except in parametric world, what's happening horizontally and vertically doesn't necessarily have to be a line. So you're breaking it down in that movement. It's also useful for describing the movement along the curve because you're no longer restricted going from left to right. You can move in a variety of directions. Okay, so you'll see this equation here. I have an example for you. You have an x equals and a y equals with t as the independent variable. And notice you have restrictions. If there aren't restrictions on t, then we might ask you to find restriction, or it could be that it's from negative infinity to infinity. But most often you'll see it restricted. Because t is our parameter, it's the independent variable. And by restricting it, we can look at just a very specific part of the graph that we would want to look at. All right, so let's talk about graphing. It's actually not that bad. Many of you take this approach when you are given something that you don't know how to graph. The easiest thing that you can do when something is in parametric mode and you have restrictions, what we suggest you do is you make a table and you plug in the starting point and the ending point, and you get a table of values. And so what I would do first is I would plug in -1 for the x, for t in the x equation and the y equation, and I would go all the way up to 4. And then I have a series of points, x, y, and then I can just plot them on the coordinate plane. Now, when something is in parametric mode, you can either graph right away by plugging in points, or we'll teach you in later videos how to convert it to rectangular into something that you would know how to graph. But either way, the first thing that you're going to do is you're going to make a table. So in this situation, we're going to make a t, x, and y table, which is kind of different, kind of new. So at the time, or it's not really time, at the t being -1, you plug it in to both x and y, and you get -2, 1.5, and you continue that process all the way from 0 to 4. And as you can see, I can come up with a variety of points. So now what I would do is then each of these just becomes an ordered pair that I would plot on the regular xy plane. So you'll see I did that. The only difference from our regular Cartesian plane is that you have to state the direction. It is not assumed to be left to right anymore. So you'll see I put a star at -1. This, or not at -1, at -2, -1.5. This is when t is -1. This is our first starting point, and it's going to continue in this direction, and it's going to end here. So you have to put an arrow on your plane curve so that we know what direction it's traveling with. And that's it. That's all you have to do. You take these t values, you plug them in, you get your graph, you tell us where you start, you draw an arrow, you're done. So it's really not that bad, but it is a lot of plug and chug. So let's try another one. So you'll notice we have x being t squared and y being t plus 2. Now we have a different restriction on t values from -2 to 2. So again, what we can do is we can make a t, x, y table, and I can start plugging in values. So if I were to take the time to do that, I would end up with these values. And then if I were to plot them, I would get this graph. Notice it's not a function. You normally wouldn't see this in the regular function world, okay? And it's going in this direction, okay? In a couple more videos, we're going to show you how to actually write the equation and go the other way. But if you were just given it in parametric, it's pretty simple to graph it. So if you want to pause the video right now and try number 3 and number 4 on the note sheet, and then I'll show you the answers and see if you got them right. Remember, all you have to do is take your t values and plug them in. Then you have to indicate which one was the starting one and the direction of travel that you went. So here's number 3. You should have gotten this. And then number 4, I actually did not plug in T is 2 and T is 3. I could have, but again, those would have given me decimal answers. So if I was not having a calculator, I wouldn't necessarily need them. So I did 0, 1, and 4 because I can take the square root nicely of those numbers. And you get this short graph. And that's how you graph parametrically. The last one is really interesting because it talks about a robot moving along the factory floor. Okay, and a lot of things, if any of you have like a Roomba or one of those like vacuums, okay, they are actually programmed parametrically because they need to figure out how they're going to move along like a grid in your home. Okay, so if you were going to have a robot move, you would really want to think about how do you want them to move horizontally as well as how do you want them to move vertically. And it doesn't necessarily have to be linear. We all know that that's not always the case. So this breaks it down into a different table. Okay, I have the equations there, and then at the end I have an x, y. But it's the same process. You take your x and your y, you take your t values, and you plug them in. And you end up with these points. And then this is a really good example of where things don't necessarily have to go left to right. So then if you were to take all these ordered pairs at these specific time intervals, you would end up with a graph like this, and this is how the robot would move across the floor. So notice we would assumed it would have gone left to right, but that's not what happened. Kind of cool. So that is how you graph parametrically. Let me know if you have any questions.